Today we're going to apply our simultaneous equations to some worded problems. So that's going to mean making the equations ourselves, which isn't too tricky because in Year 7 we did a similar topic, and using only one variable is often harder than just assigning as many variables as we need. And so that's what we'll be doing today. So we're just going to jump straight into this example. So the sum of the ages of two children is 17. And the difference in their ages is 5. So there you go, that's two equations. If Cara is the older sister of Ben, determine their ages. So we're going to assume that it's the same kids we're talking about here. So Cara is one of the kids, Ben is one of the kids. So let's call Cara's age K. Ben's age 5. And you see, the first thing we've got written is the sum of the ages is 17. So sum of the ages is 17, equation 1. The difference in their ages is 5. So K minus B equals 5. And there we go. Now, I'm going to either add or subtract them, because you can see here I've got 1k, 1k, or 1b, negative 1b. So either method is going to work. Why don't we add them? Equation 1 plus equation 2. That gets me, I'm going to do the split the page thing because I've already got the second question in there, down there. 2k. Those cancel to 0, equals 22, divide by 2, k equals 11. Sub k equals 11 into 1, 11 plus Ben's age equals 17, Ben's age equals 6. Now, this was a worded problem, so we've got to give a worded answer. Therefore, Car is 11 years old, and Ben is 6. And there we go. Solved. Next question. John buys 3 daffodils and 5 petunias from the nursery and pays $25. Julia buys 4 daffodils and 3 petunias for $26. Determine the cost of each type of flower. Now, I will say it's hard to use the letters D and P here for daffodils and petunias, because we need to remember, are we talking about the cost of them or the number of them? We often use C for cost, N for number, or sometimes X for an unknown number. And we have both of them in this question. We've got a number of petunias and a number of daffodils, but we're trying to find the cost of daffodils and the cost of petunias. So I just need to be careful. When I write the letter D, I'm thinking it's the cost of the daffodils. When I write the letter P, I'm thinking it's the cost of the petunias. So you could, instead of D and P, write cost of daffodils and cost of petunias as well, if you'd like, just to help you remember that's what you're finding. Alright, so John buys 3 daffodils and 5 petunias, and it costs him $25. Equation 1. Julia buys 4 daffodils and 3 petunias for $26. Now we need to find the cost of each one. Now, as you can see, these don't really share any common numbers here. And it's going to be quite annoying to make them. So what we're going to do, let's get rid of the cost of the daffodils. So we need to make these coefficients have the same number. At the moment, one's 3, one's 4. So I'm going to be timesing this one by 4 and that one by 3. So equation 1 times, actually I'm going to write my working out over here. So if I'm timesing equation 1 by 4, I get 12d plus 20p equals 100. And 16, sorry, timesing this one by 3. 12d plus 9p equals 78. Now, because I've made them have the same coefficient, 12d, 12d, I can get them to cancel each other out. So if I write equation 1, take away equation 2, because 12d and 12d, the way to get them to equal 0 is to subtract one from the other. I'll get, well, that's 0 plus 20p minus 9p is 11p equals 100 minus 78 equals 22. Oh, we got 22 again. Divide by 11. Divide by 11. You can see a petunia costs $2. Sub p equals 2 into, let's do number 1. Numbers slightly nicer, not heaps though. 3d plus 5 times 2 equals 25. 3d plus 10 equals 25. 3d equals 15. d equals 5. So what I did then was divided by, minus 10 divided by 3. I did that to both sides. Alright, then we write our answer. Therefore, a petunia costs $2 and a daffodil costs $5. Alright, and I've just noticed that working out was hidden. Hopefully that wasn't the case for the first one, but just in case it was, I'll leave this here. Oh no, you'd be able to figure out what the 6 is. Alright, so you can pause the video there and look at that working out just there. We'll go on to the class kick and then our textbook work, and this is the last exercise for this chapter, so well done if you're following it so far. Teaching this with year 12 yesterday, and yeah, it's still really hard then, so if you're doing well now, good on you.